Hi everyone, welcome to the AWS Workshop from Home webinar series. We hope through these webinars you will learn how AWS solutions can empower you to come up with the next idea to solve some of the world's biggest problems. Today we have Andrew Kwok joining us from our Solutions Architecture team to teach us about smart devices and the Internet of Things. If you have any questions during the session, please don't hesitate to pop them in the chat. Over to you, Andrew.
Thanks, Zoran. Hi, everyone, and welcome to the Workshop from Home series. My name is Andrew, and I'm a solutions architect at AWS responsible for helping customers develop IT solutions using the AWS environment. Today, we'll be talking about AWS IoT 101, how smart devices work. In particular, we'll be focusing on the Internet of Things, or IoT for short. We'll also be talking about how AWS enables builders to create IoT devices on the AWS environment. So let's get started. Today's agenda will cover the current state of IoT and how it's used. We'll cover the basics of AWS IoT Core, one of our services on the AWS environment, how the platform works at a high level, a basic demo of how all fits together, an introduction to our other IoT services, such as Greengrass, and lastly, we'll be providing some links and resources regarding how to get started with AWS IoT. So what is IoT and how is it used today? IoT stands for the Internet of Things, and in the simplest terms, it relates to devices that are connected to a network to share data. Today, there are a lot of use cases for IoT. You can find them in industrial IoT, smart buildings, and consumer IoT. Industrial IoT relates to industrial cloud and smart factories. So what do these actually do? Using industrial clouds and smart factories, data is brought together from all machines and systems in all factories. This allows companies to analyze processes better and become more productive when creating products in their factories. The second aspect of where IoT is used a lot is within smart buildings. A lot of buildings are using IoT to gather data regarding their space utilization, lighting, air conditioning use, power use, and occupancy rates. All this data is integrated with their building management system, so there's a unified view of how the various systems power the building. As a result, people can start finding insights into how the building is used and how to best optimize the building for minimum cost and maximum efficiency. The last aspect of how IoT is used is probably most familiar with people here. This would be consumer IoT. These relate to all the smart devices you have at home, such as an Amazon Alexa device, Ring doorbells, smart light bulbs, or any smart devices in general used within homes. These products are becoming more common as IoT's popularity increases, with new user experiences becoming available in homes. Examples of these experiences include controlling the TV or lights using just your voice or a mobile application. So what are the AWS services that allow us to build these IoT devices? Well, the service you need to look into is AWS IoT Core. AWS IoT Core is a managed cloud platform that lets connected devices easily and securely interact with cloud applications and other devices. There are many components within IoT Core, and today we'll focus on the main elements to allow you to understand how everything interacts together. Within IoT Core, there's four components: the device gateway, message broker, device shadow, and the IoT rules engine. So let's go through each of them one by one. Firstly, the device gateway is the entry point for IoT devices connecting to AWS. It manages all the active device connections and supports different protocols such as MQTT and WebSockets. It is fully managed and will scale automatically as more devices connect to AWS IoT Core. The message broker, on the other hand, is a high-throughput pub/sub broker that can securely transmit messages to and from all your IoT devices and applications with low latency using MQTT. MQTT is a lightweight publish-subscribe network protocol that transports messages between devices. So very similar to playlists of video channels you subscribe to, where if the author publishes new music, you'll get notified of this media. Message Broker works the same way. Using this same concept, instead of playlists or channels, we have something called a topic. When there's a new message published to a topic, all subscribers of this topic will receive the message. So for any clients that need to send a message, they will need to publish a message to a topic. And if the client device wants to receive messages, it would need to subscribe to a topic. We also have device shadow, which is a JSON document that stores and retrieves the current state information of a device. This service will maintain a shadow for every device you connect to AWS IoT, and you can use it to change the state of a device via MQTT or HTTP. Lastly, we have the IoT Rules Engine. This component allows you to interact with other AWS services by analyzing the topics within Message Broker, and then actions are performed on these topics. So now that we know the main components for AWS IoT Core, how does this all fit together? So let's have our smart coffee pot example to help you understand how everything works together. So firstly, let's say we have a device, which is the smart coffee pot, and we also have a mobile application that can increase the temperature for this smart coffee pot. How does this all work together and interact under the hood? So let's see what happens first. To increase the temperature, firstly, the mobile application using the AWS IoT Device SDK will publish a message to the message broker. This message broker will receive the message on the shadow update topic and subsequently send out the message to the device shadow. The device shadow will receive this message and as a result, change the desired temperature to the one set by the mobile phone. Once the device shadow changes, it will then publish a delta topic on the message broker notifying the device that there is a difference between the desired temperature and the current temperature of the coffee pot. As the coffee pot is subscribed to this delta topic, it will have the message sent to it saying there is a need to update the temperature. With the message being published to different topics, you can also use the AWS IoT Rules Engine to filter and transform the data. This is using a SQL-like syntax to create the queries, and once this is done, you can then send it off to other AWS services. Some of the AWS services you can send it to include a Lambda function for further processing of the data, or Amazon S3 Simple Storage Service for storage. The services that the IoT Rules Engine is integrated with isn't just limited to these two services. Some of the other services include CloudWatch, DynamoDB, which is our NoSQL database service, SNS, our notification service, and SQS, our queuing service. So now that we know how the coffee pot temperature changes, let's have a look at how the smart coffee pot reports back to the mobile application. Like before, firstly, the coffee pot will publish a message to the message broker to update the shadow to reflect its current state or reported state. As you can see in the Python code, I have a message that is publishing to the shadow update topic, which is the topic that can update the device shadow. How it updates this device shadow is by changing the reported state on the device shadow. So after the shadow has successfully updated, the message broker will automatically publish a message to the shadow update accepted topic. For the mobile application to monitor any changes in the current state of the coffee pot, it will have to be subscribed to this topic so that any changes can be reported. And also, like before, the messages published on the topics within Message Broker can be filtered and manipulated before being sent to other AWS services, as seen here with the Lambda function and Amazon Simple Storage Service. So now that we understand the basic mechanics of how AWS IoT works, let's have a look at what the console looks like and walk through a simple demo example. So as you can see here, this is the AWS Management Console that you'll see the moment that you log into AWS. And to access the IoT Core, you can just search it via this toolbar here. So let's go IoT Core. And as you can see here, that this is one of the first pages that you'll see. So because I have had devices connected to the IoT Core platform, you'll see different sorts of metrics present, such as successful connections, the messages, any sort of messages getting published, the amount of rules getting executed, and any sort of updates to the shadow itself. If you wanted a general recap of any of our concepts that we explained today, you can actually click on the Learn link at the bottom here. And through this, you'll be able to see exactly how AWS IoT works with this tutorial. So it's an interactive tutorial, and as you can see here, it goes through all the concepts that we explained today, such as device gateway, rules engine, rule actions, device shadows, and how to build your solutions. And then at the end, it will tell you how to get started. So this is just a very basic tutorial for good recaps if you forget anything. So as you can see here on the left hand side as well, there's actually a lot of different sorts of services that we have. To explain everything would be out of scope for this webinar, but it'd be very good for you to explore and understand all the other services that we do offer. In particular, do look into test, because what this link does is it allows you to subscribe to different sorts of messages, such as if I subscribe to the shadow update message topic, apologies. And this topic itself allows, what this allows you to do is that once you subscribe, any messages that get posted to this topic will be shown here at this point. And in terms of creating your device or registering your device, what you need to do firstly is you need to go to manage and you need to create a device. So you create a single device, and let's call this demo device. You can specify a type for this device, specify groups, and you can also add different sorts of tags and custom key value attributes to this actual device for easier sorts of searching later on. In addition to that, you can also add security to this device so that only people with a particular certificate key and private key can enter the device itself. So let's create a certificate. And through this, you need to download all these certificates for any of your programs to interact with the device registered on AWS IoT. So let's click done. And as you can see here, this is the demo device immediately. So for today's demo, we'll be messing with the coffee machine device. And within this device, there's actually a lot of different sorts of details that you can explore when you play around with the console. But in particular, we need to focus on the shadow state. So the shadow state is what we were explaining before, the device shadow. And we were talking about desired and reported temperatures. So currently this coffee machine has a temperature of 20 degrees and the reported one is 20 degrees. So both the desired and reported are 20 degrees, so there's no change or difference. So as a result, AWS IoT Core won't show a delta. And to actually change the shadow state, what you need to do is you need to click into interact and you need to publish different sorts of messages to the topics themselves. So in particular, if you want to update the shadow state, you need to publish to this particular topic. And the endpoint that is related to this topic is shown here. So within your program itself, you need to reference this endpoint. So now that we showed the basic mechanics behind the console and how IoT console operates, let's have a look at the Python script. So within the Python script, we have both a phone Python script and a coffee machine Python script. So let's explain how each of them operate first before we dive deep and learn about what it actually does. So as you can see here, that this is the phone Python script, and you're just importing the basic libraries, and then what this shows is it shows you that the temperature that you set is placed into this temp variable. And then let's ignore all of this and let's go down to the bottom and see what it actually does, right? So firstly, it connects to the gateway, it will print connected, and then it will send a message to the AWS IoT Core, and then it will disconnect. So that's all this phone does. This phone's Python script does. So what does send message do? Let's have a look at this. Send message. So send message. You can see it here. So what the send message function does is that it publishes a message to this topic. So what, as I mentioned before, this topic is used to update the shadow. So it publishes a message to update the shadow. And what message are we publishing? So if you go back further up, it's a JSON encoded message. So before it was encoded, what was it? It's actually this one. So what we're doing is we're telling the coffee machine, hey, I want the temperature to be at a specific temperature, let's say like 80 degrees. The desired temperature I want is at 80 degrees. So that's all this phone Python script does. So once it publishes it, what happens to the coffee machine? So the coffee machine needs to be able to know that there's a change in the shadow state and then change the actual reported temperature to what is desired by the phone. So let's go through this as well. So very simple. As you can see here, this is the libraries. You first initiate the client. This is the endpoint that we were interacting with, and these are the certificates that you require to interact with this endpoint at all. And let's scroll down to the bottom to see what happens. So firstly, it connects to the device gateway, and then it updates the coffee machine. So what it is doing is it's continually scanning and seeing exactly if the shadow state has changed. And what we want it to do is that if it recognizes that the shadow state has changed, it changes it and then tells us that the coffee temperature has been increased, for example. So let's have a look at this function and see what it does. Let's go back up. So this is this function. So this update coffee machine function, what it does is that first we got to subscribe to the AWS thing coffee machine shadow update delta. And then once it realizes that any sort of messages are published to this topic, it will undertake this custom callback. So what it will do is that it will read the payload and try to figure out what the desired temperature is, and then it will send a message with relation to this temperature. So what sort of message does it send? So let's have a look. So right now it updates the shadow again. This time the message that it sends is the reported message. So reported temperature. So that way it shows that the coffee machine has actually changed its temperature. So this is how it works. So I'll explain to you what this delta means by showing it through the actual demo and demonstration. So firstly, let's run the coffee machine. So currently it's observing the current IoT core and the shadow states themselves and seeing if there's any changes within the delta. And then let's have a look at the actual machine, coffee machine, and see what temperature it is at. So if we look at shadow, currently it's at 20 degrees. Okay, and we want to change this desired temperature to, let's say, 100 degrees to boil the water. So what we would do, let's minimize it. Let's change it to 100 degrees. So the moment I send it, as you can see here, if anyone paid attention just then, it changed immediately to 100 degrees. And then immediately, the coffee machine was just like, oh, okay, something's changed. I'm changing my temperature. So I read through this change, and then I changed my reported state to 100 degrees as well. But you might be wondering, so what was all that delta stuff that you were talking about? So let's have a look at the delta that will actually pop up here. So let's change it again. So pay attention to this point. So over here, I'll change it to, let's say, 80 degrees. So it changes to 80 degrees. Reported is here. Let's go through. As you can see here, there's a delta. So this is what gets published within the delta topic. And what I'm doing is that I'm reading that this temperature is 80. So that's the difference. So I need to change my reported state to 80. And that's what I need to publish to my shadow state. So that's how it works in terms of how all the different sorts of pieces fit together to publish and subscribe to different sorts of topics themselves. And you might also be wondering that how to have the phone display that the reported has actually changed, right? So what you need to do is you need to subscribe to when the shadow update has been fully accepted. So to subscribe to this, we just wrote, the client to subscribe to this topic. And whenever it's subscribed, it will read through the actual message that was updated, and it will try to find out what temperature it was updated to, and then it will output, oh, okay, the coffee machine was updated to this specific temperature. So let's have a look at see how this works. So let's take this out, save it. Let's close this program first. And now let's see. Before it was at 80 degrees. Let's say we want to change it to 75. And we got to have the coffee machine running so that it continually reads. And then at this point, when we run at 75, it changes the temperature. So it's changing the temperature. And as we mentioned before, it publishes any changes or delta to the delta topic. And then the coffee machine.py will realize that, oh, okay, there's a change in the general temperature. I need to update it. And here, as you can see here, the update was successful. So as a result, it got published to this shadow update accepted topic. And because we were subscribed to the shadow update accepted topic within the phone Python script, it immediately showed that the coffee machine was updated to 75 degrees. So this is in general how everything interacts and operates together. And I hope you understood a lot of the interactions and how topics publishing and subscribing operates and the importance of it. So now that we understood the basic components of it, let's go back to the slides. Now that we understand the basics of AWS IoT Core, let's also look at some other services that AWS provides, such as Amazon FreeRTOS, AWS IoT Device SDK, and AWS IoT Greengrass. These three services are only a subset of the large amount of services we have on the IoT platform, so let's see what they do. We have Amazon FreeRTOS, which is an open source operating system for microcontrollers that make small, low power edge devices easy to program and deploy. This is an extension from the usual FreeRTOS kernel, where we actually provide additional software libraries so that you can connect your small, low powered devices to the AWS Cloud Service. We also have AWS IoT Device SDK, which helps devices interact with IoT Core and connect with the platform. This is the SDK that we used in the demo to connect the coffee pot and phone to the AWS IoT platform. Lastly, we have AWS IoT Greengrass. This service is composed of three subcomponents, which are AWS IoT Greengrass Core, AWS IoT Device SDK, and AWS IoT Greengrass SDK. Firstly, the AWS IoT Device SDK, as explained before, is the software development kit to connect devices to the AWS IoT platform. AWS IoT Greengrass Core, on the other hand, provides local services such as compute, messaging, state, and security, and communicates locally with devices that run the AWS IoT Device SDK. So think of this Greengrass Core as providing all the components that we just discussed in AWS IoT Core, but it will run locally on your device. AWS IoT Greengrass SDK, on the other hand, allows Lambda functions to interact with the local services running inside your Greengrass core. Once you are familiar with AWS IoT Core, feel free to explore these services as a next step. So now that you understand the basic components of how everything works on AWS IoT, how do you get started building on this platform? Well, right here we have a few workshops and online videos that you can dive into and start building. So the first link on the left is a workshop using a basic development board that you can purchase online for around $10, and you can start interacting with AWS IoT Core immediately. It involves making LED lights blink, how to work with device shadows, sending SMS messages, and building out your skills for AWS IoT. So if you learn by doing hands-on activities, this would be a recommended tutorial. The link in the middle, the Foundation Series link, is a more detailed recap of what you learned today. You can go and see the theory and concepts to further understand how everything works together. And the last link on the right provides several IoT courses that you can look into as well that vary from topics such as deploying multiple IoT devices to other topics like learning more about IoT Rules Engine. So I'll keep this slide up for 10 seconds so that everyone can jot down these tutorials, take pictures to get the links. You can also scan the QR code up at the top to go directly to the websites themselves and save it. So I'll just leave this slide up for around 10 seconds so everyone can record the tutorials and links. Okay, I think that's enough time for everyone. For anyone that hasn't finished taking down the tutorials, feel free to message us in the chat window and we'll provide these links later on as well. So overall, thank you everyone for attending the webinar. I hope everyone learned something new about AWS IoT today, and I'll hand it back to Zora now to talk about our AWS Educate program.
Thank you, Andrew. That was great. I know I certainly learned a few new skills during that session. Hi everyone, my name is Zoran Teleski and I'm a Technical Program Manager at AWS. If you'd like to continue your learning, don't forget to register for the upcoming webinars, part of the AWS Educate Workshop from Home series. To go to the website, simply type in www.awseducate.com, and here you will land on the main AWS Educate website, where you will find other resources where the Workshop from Home series is one of those. So if you click onto here, you'll be able to see all the upcoming webinars over the next few weeks and beyond. Now, if you're a student or an educator and you haven't yet registered for an AWS account, you could also do that by going to our AWS webpage and clicking Join AWS Educate. If you already have an account, you can sign into AWS Educate, and by signing in, you will land on our AWS student portal or the educator portal if you are signed in as an educator. And here you can learn more about AWS technology and cloud solutions. So to find out more about smart devices and IoT, we have an IoT badge available for students to complete. This can be found through the badges option at the top bar. And by going down, you will see the IoT badge, which contains about 10 to 15 hours of learning. You can also learn about other AWS technology. For example, we've got our Deep Lens badge. If you're interested in startups and entrepreneurship, we have our AWS Startups badge, but also other technologies that are available to you through this area. If you want to explore further, we also have our career pathways, which have extended learning for students and educators. And this learning is quite particular to some of the roles that are available now within the technology industry. So if we look at some of the learning pathways, you'll see that we have Cloud Computing 101, which is sort of the basics of what is cloud computing, but then it also extends out to Solutions Architecture, which is a badge that contains about 35 hours of learning. And that will go into the details of, what does it take to be a solutions architect, similar to Andrew's role. If we go further up, students and educators have access to an AWS account through credits. So by clicking on your AWS account, you will get access to an AWS interface. So if I click into the starter account, we'll be able to access my AWS Management Console from here. So this will take me to Vocarium, and here I can see how many credits I've got left. So students over the age of 18 generally will have $100 of credits if you're part of a member institution. So click on AWS Console. If you have any questions around your account, you could see some frequently asked questions and answers in that space. But by going to the console, that will actually take me into the AWS console, which allows me to now build. And from here, I can access the technology that Andrew mentioned earlier. So for example, if I look at IoT, I can see all the different IoT services that are supported here. Thank you again for joining this webinar. We hope that we've been able to answer all of your questions in the chat. If your question was not answered, we'll follow up with you through the email address that you've provided on registration. Please don't forget to complete the quick survey after the session so that we can continue to improve your experience and bring you content that is relevant to you. Thank you again. Goodbye. Until next time.